Hello, ladies and gentlemen, and welcome to our final video of Chapter 5. Today we're going to be talking about the idea of power. So what we want to know out of all this are these three questions. You should be able to answer them. First of all, how are energy, power, and time related? We're going to be talking about what power is, so we'll be able to answer that. Second, how is power calculated? And finally, what units do we use to measure power? So let's start with what power is. So in physics, whenever we refer to power, what we're referring to is how much work is done over a period of time. So we defined work earlier. We said work is force applied over a distance. What we're basically doing is changing the object's motion by applying a force over a distance. So this is just basically saying we're doing that work, but we're also identifying in how much time are we doing it. And we want to think of it as it's a rate, just like velocity is rate of displacement, acceleration is rate of change of velocity. Power is the rate at which we do work. How fast are we doing work? How much work are we doing over a period of time? And you can also think of it as, with energy, how fast is energy being transformed over time? So power, we're just concerned with basically that energy component, whether it be work, whether it be kinetic potential energy, whatever, and we're thinking about it in terms of how fast are we doing it, over what period of time are we doing that work. So that's what power is. Now, with more power, what can we do? And if you know what the show Home Improvement is, you know he always grunted about more power. Well, with more power, what we're saying is we can do a greater amount of work. So if you have a more powerful engine, what that means is you're able to do more work in a similar period of time, and that means you're going to be going faster at the end. So more power allows you to do more work. It also allows you to transform a greater amount of energy, and we'll talk about this in a second. But with like a light bulb takes electrical energy and transforms it into light and thermal energy. So if you have a more powerful light bulb, that means there's going to be more light, there's going to be more heat, so there's going to be a greater transformation of energy there. So power is just how quickly we are doing work. The work done over a period of time. So how do we calculate power? Well, we calculate power using a couple different equations, but this is the main one we're going to be using here. We said it's a rate at which work is done over time, so it would make sense then that our equation is what's on the screen there. Power, P, is equal to the work done, W, over the time, T. Now, you can also think of it in terms of energy, in which case it's going to be power is equal to the energy done over a period of time. So either of those equations will work. You just have to think about what basis you're working on. Now, our work's going to be in joules. Same with energy. We're dealing with joules. That's the SI unit we're going to be working with. Time is going to be in seconds. So what we're really working with here is power is going to be in joules per second. So we'll get into that unit here in a little bit. But this is the first version of our power equation. How much work we do in a period of time. So that means if you're doing more work in a period of time, that means your power is going to increase. If you decrease the amount of work, power is going to decrease. And if you change the time period, that can increase it or decrease it based on what you're doing. If you're doing the same amount of work in a shorter period of time, more power. If the time you're doing the work in is longer, that means the power is going to be less, since it's an inverse relationship. So that's the first version of the equation. Now, we know the work done is force times displacement. So if we think about it with that, and we know displacement over time is velocity, that allows us to get to our second form of the power equation. And the book shows you how this happens, but we'll just leave it at that. The second version of our power equation is this right here. The power done is the force applied on an object and the object's average speed. So P equals F times V. P is power, F is force, V is our speed. It's nice and quick if we know the force applied and the speed of the object. We'll use this occasionally, but for the most part it's going to be equation 1. But you do want to know both of them so you have that basis for problem solving. And we'll do the problem solving in class as always. So, let's talk about units. With units, the main unit we want to work with is, of course, in the SI system. And the SI unit of power is called a watt, named for James Watt, a famous physicist who worked with a lot of energy concepts. We'll get to him later. So watts are the units we're going to be using here. And we have a watt. You can see it's symbolized by W. And 1 watt is the equivalent of 1 joule per second. And if you want to think of it in terms of that second equation we talked about, it's 1 Newton times meters per second. So that's the SI unit. Now, there's other units of power we can run into, and the most common one is, you can see there, horsepower. And this is, of course, the unit we use a lot in this country, since we're completely different from everyone else. Horsepower, the relationship is 1 horsepower is equal to 746 watts. So when an engine gives, it's 40 horsepower, well, you can do the conversion to get it into watts if need be. Now, this brings forth, going back to a light bulb. Light bulbs are measured in watts. You have a 40-watt light bulb, an 80-watt light bulb, all those types of things. All that number is telling you is how much energy it uses in a period of time. If it's 80 watts, that means it's using 80 joules of energy in 1 second to create light, create heat, all those types of things. So that's what the units of power tell us. Alright, so we go back to our original slide here. What should you know? How are energy, power, and time related? Well, power is the rate at which energy is transformed or used over a period of time. We talked about that. How's power calculated? We had our 2 equations. Power is work over time, and power is force times speed. And then the third, what units are used to measure power? We have watts, we have horsepower. Know the relationship between the two. In class, we'll do some problem solving with this. We'll look at some examples of how this relates to real life here, and we'll wrap up the chapter. So, thank you for watching, and I'll see you next time.